What up? Alright, I am back for another compiler video slash interpreter video. So last video we worked on the scanner and pretty much finished implementing that. Next is the parser, and before I get into parser, I did want to show a little bit of what I worked on off camera. So let's take a look. Switch that up. So a few things I added. I added all the keywords because that would have been boring to watch. I believe that might be all I did. so I think we're in a good spot. As far as there, I added a few more tests to scan for keywords. All the tests should be passing right now. If it doesn't pass, that would suck. Cool. Test succeeded. So we are able to move on. So last time we did talk about the scanner, and I added another page to my little PowerPoint just to explain what the scanner is, because I realized I didn't really explain that well what it does. So the job of the scanner is to loop through all the source files and put each thing that would be relevant to the programming language in what's called a token. So a token can be a semicolon, could be a word, it could be a number. And we want to have that list of tokens, and then we will pass it to the parser. So the parser's job is to represent the code in a tree. So it loops through the tokens, decides what has meaning as far as the tokens in the order. So if you have a statement that says let variable equal 1 plus 2, the parser's job is to represent that. So what is that? 1 plus 2, that would be a binary expression. So a binary expression is an expression with two operators, or not operators, two expressions and an operator. So the operator is the plus sign. Each expression is 1 and 2. A number counts as an expression, but also the actual 1 plus 2, the entire thing, that actually represents an expression. And then on top of that, the entire statement, let variable equal 1 plus 2, that is also an expression. So if you think about it, it is a recursive pattern, and that is why we will be using a recursive descent parser to parse through our tokens. Recursive descent parsers basically just go through the tokens and call different functions depending on the precedence of the type of expression. So certain expressions or statements have a higher precedence, meaning you check those first. Or you check them last. You check them last if they have a higher precedence. So if you're looping through and you say you hit a let expression, so the let expression will have other expressions in there. So how do you parse those? You have to loop through each one of those things and see if you have another expression in there. And if you have that expression, you're gonna recurse into it, call the function that parses that expression. If there's another expression there, you go in there and parse that one. So it's kind of like goes layer by layer down until it reaches the expression or statement with the highest precedence, and then it goes back up. So it'll be a lot easier to understand when we get into writing the code. This kind of stuff is where it gets a little complicated. The scanning was pretty straightforward. At least this is where I first struggled. So hopefully I can do a pretty good job of explaining it. And then lastly, after we parse those expressions, we're going to represent them as an abstract syntax tree, which is just a structure that represents the code in your program. So let's take a look at the code, actually. So here's our, I wrote a few functions and structures to represent the stuff just to get us going, but then I'm gonna also write some stuff as I'm filming. So for the abstract syntax tree, we're gonna have two protocols. Protocols just allows you to give a structure to a class or a struct that says it has to implement these things, it has to follow these rules, basically. There aren't any specific rules that a statement and expression need right now, but we do need to let the program know to group these together. So a function is a type of statement, an expression is a type of statement. So we create these structures, tell it it's a statement, and then have the elements of it. So a function has a name, it has parameters, and it has a body. An expression statement is literally, it just holds an expression. And then down here we have different kinds of expressions. So we have a binary expression, which is two things. So there's a left side, a right side, and an operator in the middle. And then we have a unary expression, which has only one side. So that would be, actually, I'm going to change this to right to stay consistent. So unary expression usually has an expression on the right side and an operator on the left. So the operator would just be a token, and then the thing on the right will be an expression. And then we have an assignment expression, that would be a let. So it just has a name and then a value, that is an expression. We will be adding to this as we go along. And next we have the kind of skeleton of our parser. So the skeleton, the parser will take in some tokens. It has a start position, which I don't know if I actually need. Actually, let's delete that for now. And then we have a position, which is the current position. We have peak, which is the next position. And we'll have a helper for the previous token, because sometimes we'll have to look backwards in our token array. And then we just have a helper to say we're at the end. We have a function that calls parse. Oh, also one thing I skipped over is the parser will return a program, and that'll just be a list of statements. The program represents the program we're trying to run. That was created in the source code. So what we'll do is, while we're not at the end, we're going to call parse statement and over until we hit the end of the program, and then, or the end of the token array, and then we will just return that program. And then we have some more helper methods down here. Advance just checks if we're at the end, and then increments the position and returns the previous token. Match will actually take a look at check first. Check will basically just check if the token passed in is equal to the current token, so, or the peak token. And then match, what it'll do is we can pass in multiple tokens, and then it'll loop through them. If one of them comes up, it will advance the position and return true. Otherwise, it'll return false because it didn't find that token, one of the tokens that were passed in. So from here, we can begin parsing statements. I think the first statement I want to check or try to parse will be expression statements. So that's a little confusing. There are expressions and statements, and then there are expression statements. So an expression statement is a statement that contains an expression. So try not to get confused. So we're gonna say expression. This can throw an error. So another thing I forgot to mention is we have an error up here that only has one case, an invalid token. So if we get a token that doesn't make sense in the position it is, then we will throw that. We probably want to add more robust error handling, but I am not going to do that right now. So to parse an expression statement, all we should have to do is parse an expression. So first of all, parse statement, we'll say we're just going to call expression. And then this should be expressions. And that will return a statement, actually. And then parse statement will also return a statement. So, and then since this is, we got to return here. All right, so we're returning the expression statement. And then from here, as you can see, it's not using what's returned. So we're going to say let state equal this, and then we're gonna append it to the statements of the program. So we have to make this a variable, because otherwise you can't mutate it. So append statement value of any statement. O. All right, so got that correct now. So we're just gonna actually return. So we're gonna make this method a little later, or not a little later, probably right now. But we're gonna say let expression equal expression, and then we're just gonna return an expression and pass in that expression. So I know I've said expression a bunch of times, so it's probably getting a little confusing. So what's happening right here is we are trying to parse a statement. We're checking, right now we're assuming that it's always going to be an expression statement. So we are, again, calling this. We're calling this method, and the expression statement then calls the expression function, which is what we're going to write here. And that will just return an expression from there. So, and then from here, we just check what kind of expression this is. So this could be anything that implements that expression protocol. So as you can see, right now it can either be an assignment, a binary, or a unary. So we want to start with probably an assignment. So let's see. So what we're gonna do here is, and I'm gonna double check the book actually, so I don't 100% remember. So there's a few different kinds of things to parse. So we want to start with the first type of whatever's gonna be the first thing we want to check for. So how it kind of works is we look through the different kinds of expressions. We check one, and then that one. So let's say we have, I can't spell, EXPR equals try unary. So this is not actually what's gonna be here because we want to probably check other things first, but that's what we have made. So we're gonna take that and return that expression. And then from there, we're gonna check if a unary expression. So to check if something is a unary, that means it can have a few different things. So a unary expression in this language can be either like something that's negative, so like -1 or negative variable, or it can be a not, so not variable or not true, for example. So how do we decide if something's unary? We will check to see if it starts with a stupid AI. It's annoying me. Shut up, AI. So we want to check if it starts with a minus sign or an exclamation point. So how we do that? That's where that match helper function comes in. So we're gonna say if match, and then we're gonna have types, and then we pass in the token types we want to check. So we're gonna check bang, and we want to check minus. So if it matches one of those, then we know this is a unary. So we're gonna say the operator will be the next token. So that will be either the bang or the minus. So that'll be that. Actually, I think we could use another helper function as well. So we want to say expect. So this says we expect a specific token type. If it's not that specific token type, then we want to throw an error. So expect, well, we don't want to use expect right now, I'm realizing. So, but I think we will in the future. So right now, we want to say, well, actually, let me take a look at the book real quick. I can't remember if he added something like this, actually. Well, let's just actually keep going. So we know since we checked the current token, so I'm sorry, I'm very confused. Let's see. The AI lied to me. All right, so here we go. Now I got it. So we're gonna say operator equals the previous one, and then let right equal. So what I did here, and so this is where the recursive part of recursive descent parsing comes in. So we check to see if the next token is either a bang or a minus. If it is, we're gonna go into this if statement and say let the operator equal previous, which will be that bang or the minus, and then the right side of the expression, we're actually gonna recall the expression that just called this, or recall the function that just called this function. And then we're gonna go through and do it again because there could possibly be another unary statement inside this unary statement. And that's why it has to be recursive. But once we're done parsing that expression, we're just gonna return a unary and just create it and return it. And then if it does not work, oh yeah, and then from there we so if it doesn't actually work, we're just gonna turn a call to expression. So we're basically checking if there's a bang or minus. If it is, we're gonna return a unary. Otherwise, we're just gonna go back up and call expression again. And so that should be all we need to parse expressions, but we're gonna have to make a test just to make sure it works. All right, so the source is -1. Let us scan the source. So what I'm doing here is I am just calling the scanner, scanning tokens, and then creating a parser and passing in the tokens from the scanner. And then we're gonna say program equal parser.parse. So we're just creating the program from there. And then what we expect to see, we should expect program statements count. And I don't believe this will work the first time. So we expect the count to be one statement, since that's the only thing, just an expression statement. And then program.statements.first. Oh yeah. So from there, we actually want to check what kind of statement it is. So program the statement at first as. All right, we want to check if it's an expression. So check if it's an expression statement, and then I don't know how to do it. It's a new testing. It's a new testing framework for Swift that I'm not super familiar with, so I'm not really sure how to tell it that I want it to fail. All right, I'm just gonna do this for now and Google how to do this right later. But we want to tell it if it gets here, always fail. I guess I could just do whatever to silence error warning, whatever. That make it? Okay, cool. That made it shut up. All right. So from here, we know that now statement is a expression, and then from there we want to say expect. Actually, let expression equal statement not expression unary. So what we're doing here is we're checking if that in the statement is a unary. That's what we want it to be here. Otherwise, we're gonna fail. And then from there, we're gonna say expect our expression dot operator equals minus, and then expect expression dot right. Well, actually, we can't check that right now because we don't actually have an expression for numbers. So this will fail, I'm quite sure. But let's run it anyway. So, all right, so we have an infinite loop because this never finishes. So now to make that work, we have to actually implement something to hold numbers or integers. So we're gonna go here and then an expression and then just a value, and that'll just be an int. And then we can actually go back to the test and check if that. So what we're doing here is we're checking if the right side is an integer, and then expect right.value to equal 1. So, all right, so from here we have to parse numbers. So a number, I believe, would fall in the category of primary So primary will just be some kind of literal. So it could be a number, it could be a string, and it could be another expression grouping. So from here, I'm just gonna say that returns an expression. So right now we're honestly just gonna check for numbers. So, or not even just numbers, we're gonna check for integers. And then we are going to say here, value, or let equal to this. So we're gonna get the previous token since it matched that. And then we're going to say return integer, and then the value. So value is a token, and then the token has a lexeme, which is a string, and that's where we actually saved a representation of number. This is where we get to a point where we convert it. So we have to say convert this to an int and then return it. So it's going to be a optional though. So we're gonna say so we're gonna say token here, and then if let value equal token. So we're gonna say this. Well, actually I'm gonna do a guard. So we're gonna say here, we're gonna say throw an error if it hits that guard body, and then otherwise we know the value, isn't it? So basically what this guard is doing, it's checking if this can be converted to an int. If it can't, we're gonna throw an error, and then otherwise we're just gonna return the an integer. So not sure if that's enough to make my test pass, but we'll see. We're still having an issue with, oh, I forgot to call primary. That's why. Different error. So it looks like it is still calling this over and over. Oh wait, I think I actually do know what I think I did wrong. So this should be calling itself, not expression, I think. Probably still gonna fail, but I did not run the tests. So let's see what is returned in the types. So this doesn't want to tell me what's in the token types. Let's see what could be the issue here. Let's set a breakpoint here and then see what happens. Never reaches that breakpoint. I guess as it's going down here. So let's actually put a breakpoint up here and see if call. So these calls look correct. So it's going to parse statement, going to parse expression, going to unary, and then going to primary. I wonder if we're ever getting into this part. So it looks like it's not properly parsing the minus sign. I think there's an issue with my match function, I want to say, or the check function probably. I think I'm stupid. I think I'm checking if it's at the end, but I'm supposed to be checking if it's not at the end. I think that is where I went wrong. Yep, damn. That was a very simple mistake. But we got a passing test, so that's good. So from here, so we're able to successfully parse a unary. So let's actually try to post a binary, and it knows what I'm doing. So the AI is almost correct, but it's just not there. Apple, you gotta get it together. All right, so we're gonna say what? Scan source, try scanner, scan, and then we're gonna say parser equal, and then we're gonna pass in tokens from the scanner, tokens, boom, and then we're gonna say program equals parse again, and then sorry, the program should have one statement. And then we're gonna go ahead and do the same stuff we did up here. The only difference is it should expect this to be a binary expression. And then from there, we should expect the operator to be type plus. And then we should again do a guard statement for the right and the left. So left will be an integer. write as an integer. So if we're checking if the right and left are integers. If they are, we can go ahead and then check the value. So left value should equal 1. Expect right, that value should equal 2. So this will not work, but it's good to see your test fail. So what I expected. All right, so how do we parse a binary? So if I recall correctly, binary should be lower than a unary expression. But so, well, actually there's two different kinds of binary expressions. So there's what's it called? I don't know what term is short for, but so term, we're just gonna call it for plus and minus. That is unreadable, isn't it? So for a term expression, we're gonna call plus or minus a term expression, and then multiplication and division, because those have a higher precedence, we're gonna separate that out to factors. So it's gonna be a lower precedence than unary, so we're actually gonna put it above that. It kind of goes from the top precedence, it moves up from there. So we're gonna say func term, and at the rows. So left, we're gonna say left equals a unary, because it could possibly be a primary in there. So we're just gonna say, we're gonna call the unary on the left side, and then it will go into this function. It will check if it's has a minus sign or an exclamation point inside of it, or in front of it. If it doesn't, it's just gonna move on down to primary, which is where it will parse the one in the test we made. And then, so from there, so we know it's always gonna have a left side if we get to this point. So left side will be unary, and then from there, we can check to see what the next token is. So we're gonna say, we wanna check if it's a plus or a minus. So if it's a plus or a minus, we know that, and we're in a unary expression, so we can get the operator, which will be the previous one, and then the right will call itself, because there could be another term expression in there. If I am calling it correctly, I'm not, I'm wrong. Well, the AI is wrong. So we're actually gonna check if it's a unary, and then we're just gonna, from there, we're gonna create the binary thing. We're gonna fix that. I need to stop listening to the damn AI. It doesn't know what it's talking about. So if there is correctly a binary, then it will create that, send it, return it. Otherwise, we're just gonna go here and then return a, oh, we're just gonna return the left, or the right side. Boom. Oops. No, we're not gonna return the right side, we're gonna return the left side. The left side will be that first expression we parsed. So, if we run the test, wait, no, we don't wanna run the test yet, because we wanna call term first, because it is a lower precedence than unary, and that passed. So that means we are able to parse binary expressions now. So 1 plus 2 or whatever. One good thing, as just a tip with testing though, it's good to run multiple tests on different parameters. So don't want to just check 1 plus 2. We want to check other things, I don't know, 3 plus 4, 5 plus 8, whatever, to make sure that works. Check different expressions, and I'm gonna do that in a little bit, probably off camera. I'm gonna add more tests to this, but for now this is good enough to just make sure things are working. So another thing we can check is comparison, so let's do that. next. And then after doing comparisons, I think I'm going to call it a day on this for this video. But from here, I believe we can pretty much say we get the idea of parsing expressions. It's not a whole lot of difference when it comes to this stuff, though, luckily. So, I just remembered. So this will not work if multiple expressions. This will only parse at one time. So we actually want to change this to a while loop. So first, I'm actually going to change this back and then see if the test still passes. Yes, still passes. So the reason we want to do a while loop and not just an if statement is because there could be multiple expressions in there. So we want to keep parsing through those expressions as we see pluses and minuses until it stops. Hope that makes sense. Anyway, so, all right, so we have comparison here. So we're gonna say left, and then, so comparisons are also going to be binary expressions just with different operators. So it's gonna be very similar code to what we just did. So we're gonna say left side, we're gonna check if it's a term expression, and then we're gonna do while the types match less than equal. So those are the 4 types of operators for in a comparison. So we're gonna do the same thing. Let's operator equal previous. We're gonna let the right equal a term again, and then we're gonna return binary. So it would be left, right, operator, and then we're just gonna return the left side. I also think I need to change the unary thing, because, oh, no, it's correct, I guess. Unary is correct. So this should work. So we're just gonna write another test. So we're just gonna add another thing to this test. So in Swift, you can do multiple line strings by doing 3 quotation marks. And that kind of makes it a little bit easier for writing out the source code, because that's how it's gonna be. Actually, we can also test like the new lines. So I don't think this will actually work with the multiple, I don't think this is gonna work with the multiple lines right now, because we haven't implemented either semicolons or new lines as a break between statements. So we're gonna have to do that. It's gonna be fun. All right, so we're gonna say, I'm gonna refactor this a little bit. So instead of just checking the first one, we're gonna actually loop it. So we're gonna say let the expected tokens, or not expected tokens. God, why do I keep listening to this thing? Expected state, man. Okay, so the expected results, we're gonna say will be an expression statement with first one will be an expression, and then a binary, and left will be an integer of value 1, right will be an integer of value 2, and then the operator will be a token of type plus, like seam plus, and line would be 1. So the second statement will be similar, except first side will be 10, second side will be 3, and the token will be greater than equal, name will be greater than equal, and line will be 2, and then we expect the statement to be 2 now. And so we're just gonna loop through the expected statements, and then let's date, and then the test statement will be equal to whatever's at the current index, and then we want to expect test statement to all the stuff to equal what the heck it is. So we didn't implement the binary operator on statements, so we can't just directly compare them unless we do implement it. So let's make this kind of easy for us. So how do you do this? I always forget. I don't feel like doing this. So let's see. So we know statement will always be an expression. I should fucking. So how do we check that these are equal? So I have to know that it is. I don't know how to do this. All right. So we know they're both gonna be binary. So actually, we're gonna do this. I was being silly. Boom. So we want to say that. So we're gonna check that the test statement is a binary, and then I definitely need to cut a lot of this out. So we're gonna check if test statement is a binary expression, and then from there we want to say, I think I'm gonna say this actually, and then all right, let's make this simpler actually. Boom. So we're gonna do that actually, and then so here's what we're gonna do. So what I did is made an array of binary expressions that match up with what should be here. We're gonna expect the statements count to be 2, and then we're gonna loop through the expected expressions. We're gonna get the expression, get the statement at the index that matches. We're gonna make sure that it's actually an expression, and then we're gonna test that the token, the operator is the same type, and then from there we are going to do this. We're gonna check the left and right that they're integers. We're gonna fail the test if they're not, and then from there we're just gonna say expect left that value, right that value. Oh yeah, and then we have to say, all right. So what we're doing is force casting the expression into integers, because we know they're integers. We set them up here as integers. So I believe this will still fail. Correct. All right. So I believe what we need to do is after each expression, we want to make sure that there is a new line or a semicolon after it. I forget exactly how to do that, so let's take a look at the book. Oh my god, this looks colon. So we just have to say, after we get an expression, we have to just check if there's a new line or a semicolon after the expression. So using this consume method, which not sure where that is. Let's take a look. Okay. All right, so we want this helper method, consume, and consume will check if a certain token is next. If it is, it'll just return it. Otherwise, it will throw an error, and then it takes in a token type. So consume just checks for a certain type of token. If it's not there, it will throw an error. So after expression, we have to actually consume a new line token. So we're still failing, but that is okay. Also, we want to add discardable result here so we don't get a warning. All right, let's take a look at what happened. So we are throwing an error here. So let's actually throw a breakpoint in there. See what's going on. New line. Oh, I knew that because that's what I passed in. See what peak is. Peak is new line. So not really sure why that is an issue. Oh, so I think it's hitting the end of file, and so check is at the end of the file, it returns false, and that's what's throwing the error. So consume. So I believe the issue is that we hit this new line after that, and then it tries to consume the new line, and then it actually is hitting an end of file. So let's actually see what happens if I add another new line. See if that causes it to, no, it's still failing. I think I just have that consume in the wrong place. I think I need it up here. So let's take a look at these. When it hits the end of file, I believe it is.
So it's hitting in the file, but it expects a... Okay, so I've been trying to figure this out for almost an hour, and the solution was actually very simple. I had to go back and look at an interpreter I've made in the past, but in order to terminate statements with a new line, I was having some issues. So what I was doing before is I was checking after each expression if there was a new line, but instead what I did is just in the parse statement function, I would first check if there's either end of file or new line, and if there was, I would just return nothing. And then up here, I'm checking to see if like the statement returned anything. If it returned nothing, we're just gonna move on. And then if it does return something, we're gonna append the statement and then put it in the program. I'm not 100% sure why what I was doing before didn't work, but the point is it does work right now. So also in the future, I do want to make it so you can terminate lines with a semicolon as well, or terminate statements with a semicolon. Actually, I think I have an idea of how to do that. So let's actually say semicolon 2 plus 7 or whatever. Something different. All right, so we're gonna do that. So the last statement, or the last binary, last binary should be 5, 7 plus. So this should fail now. Cool, it did. And then from there, I want to just check if the next thing is a semicolon. This may or may not work. If it doesn't work, we're gonna have to come back to this in the next video. Okay, so we failed. Let's see. Oh, well, that's expected. We're supposed to have 3 statements. Oh wait, I think it did work. Wait, no, it still didn't update. Dang. Okay, we still failed. Let's see. Expectation, left is 10, failed right is 7, right 5. What? Oh dear, I'm being stupid. Okay, so I just mistyped stuff. Okay, so this is supposed to be 5, and this is supposed to be line number 2. Okay, I think it works. Okay, that was suspiciously easy. Well, it wasn't easy. It took me an hour to figure this out. But now we are able to separate our statements via semicolons and new lines. I'm going to call it here, and we will get back to this next video. Let's put myself full screen. Thank you for watching. I am Maddie, and this has been Making a Programming Language. Hope you were able to vibe, and I hope I somewhat made it a little bit understandable, but I barely understand it, so who knows. Anyway, thank you for watching. Please like and subscribe. I will see you in the next video.